great. So welcome to sunny Wales. I thought have a bit of a different approach to the whole sort of topic. What you'll see here is the Waterton Technology Centre where DMIW is based. And of course, you can see some of the work that we're doing with Vactory, which is one of our products, and I'll sort of talk more about the sort of systems. And embedded systems, of course, is very important, but it's actually sort of understanding the manufacturing landscape that's even more important. So some of the things that we've done as well is, you know, we talked about things like haptic feedback. So when we're controlling robots, what we can do is basically put on our IoT devices, I guess, and we can actually be maneuvering and moving systems around. One of the new things that we're working on is starting to look at then the computer vision systems, and we're sort of starting to identify how we can actually bring some of these vision systems into the robot areas. But what I want to do, because Nigel has only given me 20 minutes instead of 2 hours, I'm going to literally sort of jump into the presentation. So if I can share my screen, screen one, and share, minimize everybody, and go into presentation mode. Okay, so hopefully you can all sort of see that clearly.
Yes.
Okay, great. So what I'm going to do is give you a quick sort of presentation from one of the events that we've run previously, which is the SME cluster events. Lots of this information is all on the websites, and of course the presentations are going to be available. So I'm really going to sort of run through a lot of these things. In terms of DMIW, what we've got is then a vision statement. Like I said, I'm not going to run through the whole thing. Rachel Davis is the person who's really driving this initiative. So again, afterwards, feel free to contact her. But the idea is to really sort of strengthen the support across the sort of business in Wales and start to look at the commercialization of innovation technologies. So DMIW is a non-profit organization. And like I said, we're working with large organizations as well as SMEs to bring research to business. Quick background again from my side. The reason we can do what we do is over the last sort of maybe 20 years, I've been in research projects. And currently you can sort of see I've run out of space to continue working on my little map. So I'll have to redraw this one of these days. Some of the key projects that we're working on at the moment is eFactory, the DIH for CPS, which is all about digital and cyber systems. And FactLog is actually sort of bringing us new technologies on digital twins and cognitive learning. So what I really want to sort of just give a bit of a background, because this is my perceived concerns as well. You know, we talk about AI, but it's always tricky to sort of put it into context. We talk about artificial intelligence when we talk about it in terms of embedded systems, shop floor implementation, office and home applications. Everybody's got this different adoption method. And even more importantly, nowadays, we're sort of starting to talk about psychology, philosophy. We're bringing that into the world of science and technology, and we're starting to blur the boundaries of ethics, bias, and reality. So it's a massive topic. And really what we're trying to do is capture human interaction. And part of that human interaction is trying to get genuine human emotional responses. I say emotional on purpose, because at the end of the day, what you see, and there's been some really great presentations, is ultimately we're still using logic chipsets to give us human capabilities. And more importantly, from my side of it, it's looking at it from the shop floor side. And what we're finding now is that, yes, we used to talk about hardware, used to talk about firmware, middleware, but now we're starting to inject code straight into programming systems, into firmware. So we're actually sort of into a whole new area. And one of the challenges is going to be to look at things like audit trails, especially when things go wrong. So it's going to be an interesting challenge. And talking about challenges, one of the things that we sort of try to do is to understand the implications of AI on things like manufacturing and processing systems compared to some of the things that you sort of typically hear about in terms of flying planes and so forth. So when you sort of look at it from the sort of human aspect, humans controlling and AI controlling, and then you sort of almost put it in the sense of endangering life, because ultimately that's a big measure. Obviously, human error will kill lots of people, as well as algorithmic errors. So the two things from the sort of the extreme of endangering life can potentially both cause problems. But when we start to look more at the process side of things, yes, people may get hurt generally with human errors, but when we look at processes, then maybe machines will get damaged. So it's not such a critical impact. And then overall, looking at data systems themselves, I mean, really when we talk about the Microsofts, the Apples, the Tatas, and so on, their whole infrastructure is all based on data, as we well know. And as we sort of look at these, the transformation of data now into the cloud, you know, we're still dealing with things like legacy chipsets. We've still got old servers and so on. So cybercrime is rife because, you know, there's this transition from the old to the new. And of course, the ultimate aim, you know, somebody wants to control all of the data across the whole world. And, you know, the challenges are with how do we upgrade all of these systems, and how do we sort of rely then on AI to do the system testing, because there's no way that humans are going to be able to deal with that side of the business. So let's step back a little bit and let's look at AI in manufacturing, because that's really where we're addressing these things. And one of the challenges is really to think about all the different ecosystems that take you from things like embedded systems, which is obviously what this group is really concerned about, and how those embedded systems then go into standard devices like motors, solenoids, and so forth, and then how those devices then get put into control systems like the robots that you can see down here. And of course, you need integrators to take those control systems and ultimately put them into the process environments. And really what we're doing is we're really serving the customer. It's all about the consumer at the end of the day. So what we're doing is really taking anything from that sort of chip set all the way through to the consumer, and we're providing customer demand. Now, as we move across each of these ecosystems, essentially, you know, we've got to understand that each of those ecosystems have got their own challenges. So when we're transferring information from embedded systems to standard devices, there's a whole different conversation to when we're transferring information from standard devices into control systems and so forth. And I think this is a challenge, is that what your group essentially are looking to do is how do you get that feedback back towards product design? And that's really where I see that there's this huge chasm of a lack of knowledge between those sectors. So everybody understands their own little sector, but how do you get the sort of feedback that you're looking for to develop these new systems? So, you know, when we talk about these systems, obviously we've got some of these systems down here. We got, you know, sensors that we just take for granted. We don't need to know how these things work. We simply need to know how they function and what extra ability they give us. So when we think about vision systems, yeah, you just pick up an Omron sensor and you just use it. So we don't need to worry about whether it's got all of these great capabilities. One of the things that we're doing here, though, is to look at some of these things like preventative maintenance. You've heard some of these things, you know, monitoring temperatures, vibrations, and so on. And what we've done is we've developed our own product, industryweb.com, and obviously you're more than welcome to look at that and contact us afterwards. And of course, it's a box, it's an embedded system, but it's actually connecting control systems to IT systems to web systems. What you saw earlier was really some of that information just being presented on a website. And that's what we're doing through our factory system. But we're doing more than that. We're looking at these vision systems. We're looking at preventative maintenance. And what you can do now is with the sort of the types of technology that we've got, you know, with the virtual headsets and so on, is you can literally point and click and get information at your fingertip, because all that information is already in your control system. It's all about accessing it. Instead of having to go up to the robot and press a couple of buttons on the controller and work it out, that information can be presented. And then we sort of take it further. So this is the sort of work that we're doing with the FactLog project. And we're now starting to look at cognitive behaviors, because you can digitize everything, but at the end of the day, you need the system to understand what it's trying to do. And this is the sort of work that we're really getting heavily involved with. And I'll be really interested to see some of the results of FactLog. And of course, again, if you want more information, contact me afterwards. But the real sort of area is this AI landscape. And again, it's how do we bring this machine learning, these natural processes, vision, and so on, into the sort of systems that we're talking about. And what we're playing around with, and you'll see a demo very shortly, is we're playing with technologies like, well, obviously Yellow was the start point, but we're looking at things like TensorFlow and so on. So there's an awful lot of work we're now doing on AI systems to bring them into that manufacturing area. So machine learning, vision, speech, all the things that you'd expect. So machine learning, I mean, I don't need to preach you guys, you already know. It is all about quicker, faster, better. So, you know, we're going from these big clumsy systems, you know, through to these neural network sticks. And what we're looking for is just simply things to be giving you information much, much quicker. So instead of standing there for hours trying to teach these algorithms, those things are. So it's all about improving machine operating performance. It's all about improving the user interface. You know, that's really where we're measuring a lot of this sort of information from. And of course, the sort of systems that we're using is that you're now having that knowledge, that information, that power locally. So there's no data links to external servers. You don't need them. You should be able to have enough computational power locally. It's more secure because you're not opening up your systems to the web. And of course, we're looking for more response. It doesn't mean that we don't connect to the cloud, but a lot of the manufacturing systems are all really local based. So we're bringing this intelligence from the embedded systems all the way through to the typical activities. So speech recognition, which has been around for years, but finally we're sort of starting to really pull everything together. So instead of having disparate systems, you're now starting to get the one system in itself. And so really in summary, and that's why I've really sort of blasted through this as fast as I can, because as I said, the slides are available afterwards. What we're looking for is functionality requirements. And of course, they're going to explode with a new implementation of AI and new technologies through digitization. You know, driving these embedded technologies to provide AI process technologies within control systems. So we're talking about code injections. This is something that a lot of the vendors are now really offering. So whether you go for Bosch or whether you go for ABB or Siemens or whatever, you can now start to inject your own code within their control systems. So you're no longer locked with the vendors. And of course, cyber physical systems for connected and collective intelligence. This is what SME cluster effectively is all about, is pulling these things together. What we need to do is understand that it's the individual that needs to get the benefit. And if the individual gets the benefit, then it's easy to push that into business rather than the other way around. So that was my sort of quick and dirty presentation. What I'm going to do is just sort of stop sharing the screen. I'm going to give you a very quick view. So hopefully I've caught up a lot. So if I sort of, am I back on video? Hopefully. Yep, Nigel, you can see me. Yes. So what we're gonna have is just Toby. So of course, topic of the day is COVID. So one of the things that we're using AI systems for is mask detection. So we're working with a company through one of our projects where you can actually detect the right type of mask. So it's not just about using a mask. And Toby, if you want to sort of just give us a quick sort of demonstration of what we're looking at. What we're going to try to do is actually develop a system so that people can, in controlled environments, and obviously you probably can't see it from the distance. You can see Toby is sort of showing a mask on screen. As he removes the mask, you can see that there's no mask. There's nothing too clever about that. The clever bit eventually, Toby, if you can just sort of show us the other mask that we're looking to simulate. What we've got to try then to do is to differentiate different types of masks, because in a paint shop, for example, you might be wearing a standard mask, but you can't turn certain systems on because danger. Yeah, so you're then having to start to overlay additional learning systems onto the whole thing. So again, if you're interested in some of the work that we're doing, we're more than happy to work and talk with everybody, and hopefully